push, output, push, output, push, push. And there is another push which is here, which has prevented it from moving on. It kind of tried to push, but it has stopped because another push has prevented it. So far, we have seen so many pushes and pulls. So these push and pull are called force. Actually, force is that cause which makes the stationary body moving, or a moving body, if I apply that force into it, it make it stop, or it can speed up a body. It was already moving and still it is moving by applying force, by gaining some speed or slowing down it. Or force can, you have punched this, oh my god, it is not like a punch, but okay, you have punched it and it is deformed. So what can a force do? It can speed up an object, a moving object. It can slow down a moving object. It can make a body move from rest position. It can bring the body into rest, or it can deform the body. Instead, we can say, if even it has tendency, it is not doing that, but it has tendency to do that, yet it will be called force. So force can do all these things, and force is the cause of all these things, or force can do these things. So that is force. So whenever we discuss a topic, we must have its measuring units also. How will we measure it? So measuring unit of force is Newton. Denoted by capital N. Actually, our weight is also a kind of force, which we can say gravitational force. So our weight is also a kind of force, which is gravitational force. Our weight is not our own. Actually, this is VR, and Earth is pulling us. So we think that we are pressing the Earth. No, actually, Earth is making us to press it. Earth is pulling us, and due to that pull, we experience our weight. Here I want to clarify the fact there are two terms, mass and weight. There is a confusion between both of them. So I have a separate video on it. Watch it. But here I quickly summarize. Mass, first thing, its SI unit is kg, weight SI unit is Newton. First thing. Second, it is just the matter contained, and weight is the gravitational force. These are two things. Okay, I'm writing in short, so don't complain. Next thing, mass of a body can never be zero. It can be zero. Suppose you have gone to deep space, there's no planet around you, so your weight, you will be feeling weightlessness. It is constant. Mass is constant. Weight varies according to if even on Earth, if you go to high altitudes for so much height, up to our satellites, that much amount of height, you will feel weightlessness. Next, mass has no direction. Weight has downward direction. So, this is the difference between mass and weight. Some people say that mass is measured by pan balance and weight is measured by spring balance. No, that's not true. Yeah, in fact, I would say both mass and weight can be measured by spring balance. This is spring balance, and if you have noticed, there is a hook, there's a hanger, and a pointer, and on one side it is written in grams, on other side it is written in Newton. I hope you have noticed this. So what happens then, both readings are there. Actually, from mass, if you have mass, then you can have weight, because on your mass gravitational pull exerts. So here I will tell you a easiest calculation, that if your mass is 40 kg, then multiply it by 10. Why? I can't tell you its actual reason right now. It is beyond your scope. But just think about it. Multiply something by which it will convert it into Newton. So, so that something is 10. Okay, and that 10 is actually acceleration due to gravity. That much is enough for you. So multiply that acceleration due to gravity, which is 10, into this, so it will be 400 Newton. So that demarcation is done here, but in terms of gram and Newton, we can convert gram into kg and then kg into Newton. So that demarcations are done here and here. So uh, for 1 gram, let us suppose 1 gram is very less. 100 gram, 100 gram is actually 0.1 kg. Now multiply it by 10, so it is 1 Newton. Simple mathematics. Okay, so forces are contact, non-contact. Contact forces in which actual mechanical contact is required. So all the forces which we see around us are contact forces. But there, in the demo, I have shown some forces where there is no physical contact, like electrostatic force, where I attracted paper pieces by comb. So it was non-contact forces. electrostatic forces. And there was magnetic force. Actually, I used a phone, its speaker, in front of its speaker I just hung that needle, and it get attracted toward the phone. That was magnetic force. So magnetic force are also non-contact force. And simply this, it is pulling down by gravitational force. So gravitational force are also non-contact forces. Okay, in senior classes, there are few more non-contact forces. Anyway, first, this much is enough. So, but other than this, force can also be classified. In fact, forces, number of forces. So they can be classified as balanced forces, unbalanced forces. All right, so as the name suggests, so uh, let us suppose this is an object, and from different sides, number of forces are acting on it, yet it is not moving. It is fixed. It is stable. It is in equilibrium. So we will say that it is subjected to number of balanced forces. All the forces are balanced forces. But if the number of forces are acting on it, yet it is moving in a particular direction, then we will call it unbalanced forces. The best example for balanced force is this marker. Its weight is pulling it downward, and the reaction exerted by the earth uh, is balancing it. Now you would say that how is it possible? Actually, earth is pulling it down, yeah, but when it is in contact, there is action and reaction. So both are becoming balance. In the same way, again, that brick, it has helped me a lot. Its weight is acting downward, and from this surface, it is receiving an upward push also. If it wasn't there, it would be, sagged inside it. But there is a balanced force. Now I am exerting another force. You can see I am applying force, not enough, but I am applying. And frictional force is preventing it from moving. So there are four forces: weight, downward, reaction, upward, external force this way, and frictional force which is preventing it. If I cross that barrier of frictional force, I apply the force more than that frictional force. Now these forces are unbalanced forces. So unbalanced forces are responsible for the motion of an object, and that's all for this introductory topic on forces. I hope you have liked it. If you have any query, any confusion, any problem, comment me. Bye bye.